Hello, welcome to Special Maths Academy. In this video, we'll be looking at solution to the just concluded Special Maths contest. For this problem, we see that we're looking for the probability with a condition. So this is a conditional probability. We can use a conditional probability formula, but I'm just going to go through going to break it down without just jumping straight into the formula. So we're going to go back to the basics. What we're going to do is we see that we have X blue, Y red, Z yellow identical balls. So this means in total we have X plus Y plus Z balls. So what we're going to do is we're going to actually take the balls as individual distinct balls. So this way we can easily compute the sample space for our probability, so that every ball will be equally likely to be chosen. So that means for the X blue balls, we can just label them like some sort of B1, B2, all the way to BX. So this will be the X blue balls, and then we'll have R1 all the way to say RY, and then Y1 all the way to YZ. So this way they are all individualized, right? So we can keep track of which ones we are picking and so on, and then after that we can tell which color they are. So now we're picking 3 balls at random, so they're all equally likely with replacement. So this means that after the first selection, the second selection, everything comes back to the initial setup, so it's going to be independent of whatever the previous outcome was. So that independence means we can just multiply when we try to calculate the numbers of possibilities. Okay, so what's the sample space? Well, we just have triples of balls we can pick. P, Q, R, for example. Here R is not right, just PQR. So this, if we use PQR, P will represent the first ball, Q the second ball, R the third ball. Okay, so the sample space will just be whereby P can take any of these values, Q can also take any of these values, R can take any of these values. So in fact, we have the total of X plus Y plus Z raised to power 3, because we just multiply this in each case since they are independent. So this is the usual sample space. But now, for this problem, we are given a sub-sample space. So that means just a portion of the original sample space is what we're actually considering before we consider the probability. So what we're given is that the first 2 balls are of different colors. So if we go with that sample space, that means we're assuming that P and Q have different colors. We don't really care about R. So this means that for the coloring style, we could have blue red, red blue. We could have blue yellow, yellow blue, or we could also have red yellow and yellow red. Okay, so if we do this this time around, we can calculate each of them, and since they are mutually exclusive, we cannot have any 2 at the same time. It means we can just simply add up whatever we have. So for the first one, to get a number here, we see that blue we have X of them, times, since they are independent, we just multiply now, times for Q we have, for red, that's Y of them, then for R, it could be any of them, so we have this as well. Then we just repeat the same procedure for the remaining ones. Okay, so we have something like this, and we just add this up. Clearly we can factorize, and we see that some of these terms repeat like twice each. So as a matter of fact, this will just be 2 into xy plus xz plus yz into x plus y plus z. So this is the new sample space. Then now we can go ahead to see what are the favorable outcome. So this time around, the third ball also have to be different. So it means that all 3 are different. So now it's just going to be similar to what we did before. This time around we could have the same blue red, but then the last will have to be different, so it can only be the third color. So actually we just similar pattern to what we had before. The only difference is the last one will now be the third color we've not picked so far. So we just have the same composition. So this is remaining red, red, blue, blue, and this is just going to affect the outcome just a little bit. So now the last will have to be yellow, so there are Z of them, and here we just see that we just have a different permutations of X, Y, Z. So we have X, Z, Y, Z, X, Y, Y, Z, X, and Z, Y, X. And once again we add this up. Well, here we just get simply 6xyz, and so the probability now is just going to be 6xyz over the sample space, which is 2xy xz yz, and we can factor out 2 here, cancel that out, and then we can divide numerator and denominator by xyz to get so xy xz yz over xyz, and then we still have x plus y plus z, and this will just be exactly what we have in option D. Okay, so this is the correct option for this problem. I hope you enjoyed, so I'll see you in the next one.